Hello guys, welcome back to another video. Today we are going over a chapter problem from the team round of the 2025 to 2026 Mathcounts series. So this is from the team round, and the question is, 3-unit circles are externally tangent to one another as shown. From each circle's center, there are two lines that pass through the center and are tangent to exactly one of the other circles. These 6 lines form a hexagon. What is the area inside this hexagon but outside the 3 circles? Express your answer as a decimal to the nearest hundredths. So, where I would like to start is I created a equilateral triangle inside of this hexagon, as you can see here. And the sides pass from where the circles are tangent or touching, so the sides of the triangle are 2. So the area of an equilateral triangle, the formula for it is basically it's side squared times the square root of 3 divided by 4. So if we do that here, then we find that 2 squared, which is the length of this, times the square root of 3 divided by 4 is square root of 3. And if you look even closer, you can find that the area of this equilateral triangle is half of the area of this whole hexagon. To make it clear for you, I shall divide the triangle into these 3 parts and then compare it with the remaining 3 parts. As you can see, these 2 parts are identical, and basically if we were to take this region as a whole, we would see that the whole hexagon this would be a third of the whole hexagon, right? So using this evidence, we can conclude that this is half of the whole hexagon. So now we know that the area of the whole hexagon is 2 root 3. So basically, now that we know the area of the hexagon, all we have to do is find the area of the circles. So here it said unit circles, 3 unit circles. So we know that the radius of this circle is 1. And since there's a hexagon here, and each hexagon has one of its angles as 120 degrees, so there are 3 circles here, and the angles each intersect the center. So 120 degrees times 3 is 360. So the length of these 3 arcs added together is 360 degrees. So we have basically one whole circle. We have to subtract one whole circle from this hexagon. And basically, using the formula for the area of a circle, pi r squared, we find that the area of the circle is pi. So 2 root 3 minus pi. That's a very bad pi. So if you do the calculations, you'll find out that this 2 root 3 minus pi rounds to 0.32. Now I'm going to cover another way you can do it. So another way you can find it is you can find the area of the circle. What you did first is pi, so you have to subtract pi from the whole of the hexagon, right? But now another way you can do this is you can use the formula for the area of a hexagon, which is 3s squared times root 3 over 2. So now all we need to do is find this length. So what we can do is we can use a 30, 60, 90 triangle over here, and we see that this length is 1, 1, that looks like a 2, just know it's a 1. And so using the properties of a 30, 60, 90 degree triangle, we'll know that this length would basically be, let me think. So this would be 4/3, the square root of 4/3. So right here, s squared would be 4/3. When you multiply this, then this would be 2 root 3. And you can actually look it up, the properties of a 30, 60, 90 degree triangle, but it involves trigonometry, which is why I would prefer the first approach over this one, because unless you know like trigonometry and have triangle values memorized, it won't be easy to find an answer to this. But both approaches work, and you do get the same answer, which is 0.32. Yeah, both approaches work, but I would recommend the first one. But that's all for today, and goodbye. I wish you good times for the rest of your day. Peace.